Welcome. We'd like to use what we call the square root property to help us solve some quadratic equations. First, let's discuss what that square root property is. When I have the scenario of square rooting a variable squared, what I get isn't just x. I'd like it to be. Most people think it is and use this, but this is not the case. So if this is not the case, what is the reality? Well, let's consider just a couple of simple scenarios. If I take the number 3 and I square it, so I'll take 3 and square it, I'm going to get 9. Okay, we all can agree with that. I don't think there's any issue there. When I square root that, it always results in the positive version, right? It always results in a positive number. So the square root of 9 is 3. Okay, so the square root of 3 squared is 3. Well, doesn't that show that the square root of x squared is x? Sure. But we also have the ability to take -3 and square it, which also gives us 9. And when we square root this, square root of 9 is still 3, right? The square root of 9 is 3. The square root of 9 is 3. But 3 and -3 are not the same, right? I didn't start with 3 in both cases. So the result is not just x, because I did not end with the thing I started with. Rather, the result is the absolute value of x. It always results in the positive version. 3, absolute value of it is 3. -3, absolute value of it is 3. That's what we get. So this is what we call this. Well, that's not really what the book that we're using calls the square root property, but this is truth. Okay, this is a better explanation than just saying, we magically get 2 answers, which we'll see what's going on there in just a moment. All right, we previously looked at some basic absolute value equations, which are going to come into play at this point. So if we want to solve this quadratic equation, if I wanted to factor this, I could. It might not be super easy, but I could. However, if I want to use the square root property, what I can do is I can get x squared alone by adding 8 to both sides. Once I have x squared alone, I can square root both sides. The square root of x squared gives us the absolute value of x. If we want to simplify the square root of 8, we can do so, and we should, which results in 2 times the square root of 2. Now, the absolute value equation that we have found may be solved by saying x is equal to exactly what's on the right-hand side, 2 times the square root of 2, or x is equal to the negative of that, -2 times the square root of 2. And these are the solutions to our quadratic equation. Wonderful. Very convenient scenario here. We could also encounter a scenario in which we have not just x being squared, but x plus or minus something being squared. Now, we already have the square isolated. This thing, x minus 2, is being squared. So I can immediately just square root both sides. Now, the square root of 9, as we previously discussed, is 3. So I have the absolute value of this thing, right? This thing being squared and then square rooted results in the absolute value of that thing. That thing is x minus 2 in this case. So the absolute value of x minus 2 is 3. That results in x minus 2 is equal to 3, or x minus 2 is equal to -3. I can solve each of these by adding 2. So x is equal to 5, or x is equal to -1. This gives us our 2 solutions to the quadratic equation. Now, we didn't have to write this in the form ax squared plus bx plus c is equal to 0. We were simply able to manipulate this particular representation. It was wonderful. We have a very similar, essentially the same situation here. We just want to point out that, hey, we could have subtraction in between, or we could have addition in between. So we square root both sides. Square root of x plus 5 squared, square root of that quantity, is equal to the square root of 18. Now, 18, you'll want to notice, is 9 times 2. 9 we know the square root of, right? That's 3. So I can say the absolute value of x plus 5 is equal to 3 times the square root of 2. Again, 18 is 9 times 2. The square root of 9 is 3, and we still have that 2 underneath the radical. This gives us x plus 5 is equal to 3 times the square root of 2, or x plus 5 is equal to the negative of 3 times the square root of 2. We can isolate the x by subtracting 5 from both sides. X is equal to negative 5 plus 3 times the square root of 2, or x is equal to negative 5 minus 3 times the square root of 2. And these are our solutions to the quadratic equation.